lightning conductor. It was the American scientist Benjamin Franklin who showed that static electricity, formed due to friction between the droplets of water and particles in rain clouds, results in lightning. In 1752, Benjamin Franklin conducted an experiment with a kite to find out if lightning was electricity. When the kite entered a rain cloud, the negative charges in the cloud leaked onto the kite string, key attached to the string, and a Leyden jar attached to the key by a thin metal wire. Franklin, however, was unaffected by the negative charges because he was holding a dry silk string which insulated him from the charges on the key. When Franklin reached out his knuckle to touch the key, he received a shock because the negative charges in the key were so strongly attracted to the positive charges in his body that a spark jumped from the key to his hand. Franklin's experiment successfully showed that lightning was actually static electricity. A lightning is a gigantic electric discharge between two oppositely charged portions of a cloud, or between two charged clouds, or between a cloud and any object on the surface of the earth. Let's first see how a cloud gets charged. Within a thundercloud, many small bits of ice bump into each other as they move around in the air. These collisions create electric charges. Eventually, the whole cloud gets filled up with electrical charges. The positive charged particles stay light and rise to the top of the cloud. The negative charged particles get heavier and collect at the bottom of the cloud. As more and more particles become charged, they divide as positive and negative groups in the cloud. When the power of attraction between them gets too great, the particles discharge their energy at each other, completing a path for electricity to travel through the air. We call this flow of electricity lightning. This is intra-cloud lightning. If the electric discharge is between two charged clouds, then it is inter-cloud lightning. Intra-cloud and inter-cloud lightning is a common sight during a thunder shower. At times, the electric discharge can take place between the cloud and the earth. This type of discharging is called cloud-to-ground lightning. This type of discharge can be dangerous. Negative charges at the bottom of the cloud cause lightning to strike the ground. The negatively charged particles group together and seek out positive charges from the ground. The excess electrons inside the cloud create a channel of charged air called a leader that reaches down looking for positive charges. The leaders attract other channels of charged air created by protons on the ground. These charged ground-based channels are called streamers. When the stepped leader from the cloud meets a streamer from the ground, a conductive path is created. An electrical current called the return stroke travels from the ground to the thundercloud. This return stroke releases tremendous energy, bright light, and produces thunder. Thunder is the sound that follows a flash of lightning and is caused by sudden expansion of the air in the path of the electrical discharge. A lightning discharge passing through a building can cause serious damage. However, a building can be protected from such damage if a lightning conductor is installed. A lightning conductor has a flat, thick strip of copper with several copper spikes projecting from it and is placed at a height above the building. The lower end of the copper strip is connected to a copper plate buried deep in the earth to provide good earthing. When a charged cloud passes over the building, negative charges at the bottom of the cloud induce positive charge in the spikes and negative charge in the copper plate buried in the earth. The discharging action of pointed ends set up an electric wind of positive ions, which neutralize the negative charges in the cloud. This decreases the potential of the cloud. The negative charge of the copper plate is neutralized in the earth. On the other hand, if a lightning strikes the conductor, an electric discharge passes down to the copper plate and into the earth, which is a large uncharged conductor. Thus, lightning conductors save buildings from damage. Flash to bang method is used to estimate the distance between an observer and a lightning flash. If you observe lightning, count the number of seconds until you hear thunder. We know that velocity of sound is equal to d by t, where d is the distance and t is the time taken. The distance between the observer and the lightning flash is calculated using the formula d is equal to v into t. Lightning may strike several kilometers away from the parent cloud, and precautions should be taken even if the thunderstorm is not directly overhead. According to the 30-30 rule, if the time between the flash of lightning and the subsequent bang is 30 seconds or less, take appropriate shelter, and remain sheltered for 30 minutes after the last thunder. Lightning makes every single thunderstorm a potential killer. However, following certain lightning safety guidelines can reduce the risk of injury. Remember, you are responsible for your personal safety and should take appropriate action when threatened by lightning. Observe the visuals carefully. Decide which one is the safest option and click on it. If you are in an open level field far away from shelter, kneel on the ground immediately. With feet together, place your hands on your knees and bend forward. Don't lie flat. Avoid being the highest point in an open area. Whenever there is lightning, stay away from water. Return to the land as quickly as possible if you are on the water. Don't stand in puddles even if you are wearing rubber boots. It is safer inside a car during lightning. But don't park the car near or under trees or other tall objects which may become a path of discharge or collapse during a thunderstorm. Be aware of downed power lines which may be touching your car. If you are trekking through a forest, seek shelter in low-lying areas, under a thick growth of small trees or bushes. Stay away from objects that conduct electricity. When you are in a group in the open, don't stand close to each other, but spread out. The safest location during a thunderstorm is inside a large enclosed structure with proper plumbing and electrical wires.